Hi guys, my name is Alexis O'Connell and we're talking about collision using the momentum principle. A frog is sitting on a lily pad and he darts his tongue out to catch a delicious fly. We're trying to find the recoil speed of the lily pad and the frog after he sticks his tongue out. So in order to find this, we are given the velocity of the tongue when he initially sticks his tongue out, the mass of the tongue, which is 0.00047 kilograms, and the mass of the frog, the rest of the frog, other than the tongue, plus the lily pad, is 0.0125 kilograms. And you needed to find the recoil speed of the frog and the lily pad. So we have to use conservation of momentum, which says that final momentum should be equal to initial momentum if the momentum is conserved. And for collisions, momentum is conserved. So we use that formula, and we know that momentum is mass times velocity. So we have the mass, so this is the final situation and this is the initial situation. So, this is the initial situation before you did the math. And so, in the final situation, you have the mass of the tongue plus the mass of the frog plus the lily pad as the mass of the system times the final velocity, which should be equal to the mass of the tongue times the velocity of the tongue. So in order to get the final velocity of the recoil speed of the frog plus the lily pad as it shoots back after he shoots forward, you need to isolate the variable v, and to do that you divide by both masses. So you divide by both masses, and you should get this. And then you have your final velocity, and you just plug in those values. So mass of the tongue times velocity of the tongue divided by mass of the tongue plus the mass of the frog plus the lily pad should give you that over that, and that gives you this when you plug in the calculator. So that is the conclusion of this problem, but I added another portion of this problem, and we're asking, is kinetic energy conserved? And if it is conserved, the final kinetic energy should be equal to the initial kinetic energy. And in order to solve this, I assumed that the velocity that he shoots out the tongue is equal to the velocity that he shoots in the tongue, shoots back the tongue back in his mouth. So in that aspect, I assume that when he shoots the tongue back in, he's colliding with the body and the lily pad to create this movement. So in order to solve this, I said that, let me focus this really quick. Okay. I said that kinetic energy should be the change in kinetic energy, so final minus initial. So we need to calculate the initial and the final in order to subtract them both. So I said that 1/2 mass times velocity squared, and this is for the tongue, the initial situation. And I plugged that into the calculator, and I got 0.003217 joules. And then I said that the kinetic energy final of the system, and I said that this system is the mass of the tongue times the velocity of the tongue plus the velocity of the mass tongue lily pad system that we found answer to this problem above, and times the mass of that, and which is different, so I'll just say mass 2. So I plugged those values in: mass of the tongue, mass of the the whole system, the lily pad, and the frog, and plug that in, solve that, and I got 0.00403, which 0.003217, 0.00413, and those are both joules. And they're pretty much almost equal, so I would assume that, well, not assume, but I would conclude that the kinetic energy is conserved. And in this case, if this tongue is shooting back into the system, that means it's an inelastic collision, and for that part of the problem, kinetic energy would be conserved. So yes, that concludes. Thanks for watching. Thank you. Have a great day.